Let's see the GATE questions on stacks. So again, a previous kind of a question. How many push and pop operations will be needed to evaluate the following expression by the reverse Polish notation? Means reverse Polish notation means it is postfix. Okay, in a stack machine. So this is the expression given. How many push and pop operations will be required to evaluate this expression? So you have to convert this to postfix, right? Evaluate the following expression. So do it to postfix and then find out the number of push and pop operations you needed to evaluate this expression. Okay, so please give an attempt, try to find out what is the answer. Some options are given here. See, you have to write the postfix notation for this first, then evaluate that. During evaluating the postfix notation, how many push and pop operations are required, right? You will be pushing elements and then you will be popping out the elements accordingly. So please find out the answer. No, take pen and paper, try to solve this. Then after giving a pause, you see the solution which I am discussing. Let's analyze the answer for this. So first I have to convert infix to postfix. So again, we will write it A into B plus C into D by E. Okay. So here it is not clear for the students that is it that first I have to convert it to infix to postfix, find out the number of push and pop, and then should I count the evaluation also, or is it directly for evaluation? Let's do the evaluation first. So this becomes in postfix AB star. This becomes again in bracket. Multiplication I have more priority. So it becomes CD star E by, right? Then comes plus. So the expression is AB star CD star E slash plus, right? This now I have to evaluate it. So what I have to do here, I'll take account push and pop, two variables will take. Okay, A means I have to perform push once, so 1. Again B, so I have to perform push, so this becomes 2. Star, I have to pop it out, so pop is happening. How many pop operations I'm doing? See, I'm doing 2 pop to delete these 2. Okay, I'm doing 2 pop operations to delete these 2. So again, it is not 2, we'll consider it as 1 pop operation. We are popping out the elements. That way we will let us see, right? So or otherwise this only 2 pop I have done. Now after that the result will be pushed into the stack, that is A star B will be pushed onto the stack. Then came C, place it as it is. Then came D, place it as it is. So 2 push, so this became 4 now, right? And the result also went, so it became 5. Result also came, it became 5. Then we have star, so you have to pop the elements. Which 2 you have to pop? The top 2 you have to pop. So top this became 4, and that result will also go into the stack. So this becomes 6. Now after this we have E, so push it onto the stack. Then you have divide by. When you have divide by, you have to pop 2 elements. So 1 push happened for inserting E and 2 pop happened for deleting, right? So that final result, that result will again come here. So this becomes 8 this time. Then you have divide by is over, then you have plus. So again you have to pop out these 2 and perform the operation. So this becomes again 6, and this is 8 only, push, we did not do anything. So 8 and 6. So this way if you see, we are getting 8 and 6. Okay, we are getting 8 and 6, but that none of the answers is matching. Even if you do in the exact operation, none of the answers is matching. So for this the answer is 8 push and 6 pop. If you are doing it using the postfix notation to evaluate the expression, right? So here options are not matching. That's what is given in the internet. Let's see the next one, right? The next interesting question here. Consider the following infix expression which is to be converted to postfix expression using stack. Sum of, what is the sum of all unique possible heights at each pop? At each pop, what is the sum of all unique possible heights of the stack? Meaning when you are converting an infix expression to postfix, right? What you are doing here, see, you will be taking the character, you will be reading, maybe I will write that table which we always used to draw, that is input, then the operation, then the stack, and then the postfix expression, right? So the question here is the sum of all unique possible heights at each pop. After popping the element, what is the heights of the stack? Unique heights, some they are asking. Okay, it means you have to implement the no infix to postfix expression. That table you have to draw for this whole lengthy expression, and during that time your stack value, your stack height will be different. No, sometimes open bracket to 3 times, then plus, then again it becomes only 2 like this. Sometimes it is 1, sometimes it is 4, some minus like this. So all the unique heights, some they are asking here, right? So please try to convert this expression to postfix expression. P plus Q, very lengthy expression. Try to convert this to postfix, and then observe the stack values. Observe the stack values whenever you do the pop operation, right? That sum they are asking. So please give an attempt to convert this. Just to draw the table for converting this given infix expression to postfix. From that table we can generate the answer for this. Okay, so please try. So when you are pushing those elements onto the stack, right? So initially it is one open bracket, so we push that onto the stack. Then it's another open bracket, again we push it onto the stack. Then the third one we push it onto the stack. P will go into the output expression. Then came plus, we add it to the stack. Then came Q, we pop it out. We will send it directly to the output expression, right? Then after this came round close bracket. Whenever this close bracket comes, we have to pop the elements until we encounter a open bracket. So this is the stage. So one pop happened here, right? Sum of all unique possible heights at each pop. So here we did the pop operation on this. Again, this, let us note down this as the pop operation. Next, you got multiplication, you have to add it onto the stack. You got open. So when there is this open has come, it is open like this. Then R output plus, add it. Yes, again output. Close means you have to pop it out. Close means you have to pop it out. So these two you will remove. Okay. So let us not do that. Let's do it here, right? In the another expression. So this becomes C plus like this. Oh, sorry. We have to pop out this, goes away. Then came another close. Again we have to pop it out. So it became only open, only round, right? Then came divide by, means I have to put here by T. Then came T goes away. Then came the close bracket. When this close bracket comes, what you have to do? You have to pop out. So I am popping it again. Stack becomes empty this time. Stack becomes empty stack, right? Again plus came, I have to insert. So my stack becomes plus. Only element in the stack is plus. Again open bracket, so plus open bracket. Then A output star, insert star here, plus C star like this. Okay, so you keep doing the logic in this way. You expand, keep that table. Then whenever you are performing the pop operation, right? In that case, what is the height? See, here you are doing, this is 2, right? This is 3, this is 1, right? Like this, wherever you did pop operation, the heights of the stack, unique heights of the stacks, you can count it. So can you count it and tell what is the answer you got there? If you count it, what answer you got there? You please find it out. So for this problem, if you solve it, you get the answer as 15. You draw the table and try to solve it, you get 15. See the next question here. You are given a infix expression and some priority order is given to you. Based on this order, find out the postfix expression for this particular infix expression. What is the infix expression? We have A plus B into C minus D exponential E exponentiation F. This is the expression, right? And what is the precedence given here from highest to lowest? This has high priority, then has multiplication, then is plus and minus. So exponentiation has high priority. You have to convert this infix expression to postfix. See, we may do it using stack also. You can draw a stack, keep pushing it, popping out. You can do that way also, or otherwise directly also you can solve this question even without using the stack, right? So let's analyze the answer for this. Let's see the answer for this. I can even do it directly because I know this has more priority, and this is right associative, means I have to do it from right side. So I will do this first. So this becomes EF exponentiation. Then this D exponentiation, this parameter, right? So this will come out this side. So it becomes like this, DEF. So the only option you can see where we have DEF and double cap is only this option. With that only you can conclude, but even you can verify it whether we are getting it or not. Then the leftover expression is A plus B into C minus this one term. Next, what is the highest priority one? Multiplication. That is from left to right. So it becomes A plus BC into minus this term, cap. Now we have plus. So do that. So it becomes ABC into plus minus DEF exponentiation. At the end, this one, and followed by minus. So option A is the right answer for this. Let's see the next one. The program attempts to generate as many permutations as possible for the string ABCD by pushing the character ABCD in the same order onto the stack. But it may pop off the top character at any time. Which one of the following strings cannot be generated using this program, right? So you are having 4 characters ABCD, you are pushing those characters onto the stack. But sometimes you can pop it out also. Insert 1, pop it, insert 1, pop it, insert 2 and pop 1. Like this you can do any permutations, right? Which among these four are not possible in that pattern? Cannot happen in that pattern, right? So inserting them in the same order as ABCD and popping it out. So which one cannot happen among these 4 is the question. Okay, so please give an attempt, try to solve it and identify which one is the answer. Then you can go to the solution which I am discussing. Let's analyze the answer for this. See, I have to insert the elements ABCD. We will go by options. We will try to go by options. So I have the characters A, B, C, D with me. So I will push A onto the stack and I'll pop it immediately. So I get A. Then push B and pop it. I get B. Then push C and pop it. So it becomes ABC. Same way, put to D and pop it out. ABCD. This is possible, right? So the next case. Next one is DCBA. DCBA. Push all elements A, then B, then C, then D and pop this element. So I'll get D, then I'll get C, then I'll get B, A. This also is possible. Then take the next one, that is CBAD. Okay, so put A, I want C, B, A and D. Put A, then put B, push C. Now pop it, pop the C, so C comes out, pop goes away. Then pop the B, so B goes away, B comes here, right? Then pop the value A, so A comes here, the stack becomes empty. Now push D into this and then you pop it out. This is also possible, CBAD, right? Now the final one, that is CABD. CABD. Okay, in this case what will happen? To get C, I will first insert A, then B and then C. So pop it out the C, I get C. Okay. Then I want A. No, it is not possible. I have to delete B and only do that. So in this case, the answer is this. This string is not possible. Yes, we will see again these questions. Again, similar questions are there. Let's see. Yeah, see this one question we will see. Single array, a single array A is used to implement 2 stacks. The 2 stacks grow from opposite ends of the array. Okay, They grow from like we have seen the implementation of two stacks in a single array, right? Variables top 1 and top 2 point to the location of the topmost element in each of the stacks. We use two variables, top 1 and top 2, right? If the space is to be used efficiently, the condition for full stack, implementing two stacks on a single array, what is the condition for stack overflow? What is the condition when the stack will be full is the question. So analyze the four options and identify what is the logic for the stack to be full in a implementation of two stacks in a single array. Let's analyze the answer for this. In what case the stack will be full or the array will be stack full condition, right? Suppose see, this is, here is my top 1 and at this location we have top 2, right? So at any point, maybe I am having 4 elements in stack 1 and 3 elements in stack 2. So my top 1 is here and top 2 is here. What is the index? 0, 1, 2, 3, 4, 5, 6. See, when we can say the stack is full, whenever the difference between the two top pointers is 1, right? That's what top 1 equal to top 2 minus 1. When top 1 value is equal to top 2 minus 1, then this is the case that the stack is full. Okay. Again, programming, I will just focus on, time complexity based question. Suppose a stack is to be implemented with a linked list instead of array. Okay, stack is to be implemented with a linked list using an array. What would be the effect on the time complexity of the push and pop operations of the stack implemented using linked list? Okay, so what is the time taken for insertion and deletion? What is the time taken for insertion and deletion of the elements on the stack? So if you are using linked list logic, what is the time complexity of push operation and what is the time complexity of pop operation? This is the question, right? So how can you guess the answer for this? What is the so it's very quite clear. We know that the implementation of linked list is the easiest for stack. Why? The push operation is nothing but insert at the beginning of the list. Okay, pop operation is nothing but delete at begin of the single linked list, and both will take only a constant time. That's why it is order of 1 time complexity for both the operations. For insertion and for deletion, both it will take 1 each. Again, given an infix, convert that to postfix. You can solve this easily, right? Stack A has the entries ABC with A on the top. It is something like this. So A is on the top, then is B, then is C. Stack B is empty. An entry popped out of stack A can be printed immediately or pushed back to stack B. An entry popped out of stack B can only be printed. Okay, in this arrangement, which of the following permutations of ABC are not possible? There are 4 permutations here with A, B, C and D. Among those 4 permutations, which of the following permutation is not possible? Logic is simple. You have stack A and stack B here. Okay, so there is no size given of both the stacks, right? An entry popped out of a stack can be printed immediately or it can be pushed onto the stack. So using this logic, you tell among the following combinations which of the following permutation is not possible. Which permutation is not possible? Give a try to solve this problem and tell which one of the following permutations is not possible.